Okay, hello everyone. This is an introductory session to Git, the version control software. I will start. I have this drawing tool. This is called Excalibur. It's a free online drawing tool. I'm going to draw a lot because I think it will help me explain and help you understand the concepts around Git. Also, all these resources, like for example, this tool, Excalibur, some other services that I'm going to be using and tools, we will share them with you when we upload the video on YouTube, the recording. So we will place all these resources and you can find all these links later on. So don't try to waste your time, like looking for the links now. We will share them later on. Before going into Git, which is a command, it's a program that you can run through the terminal. I'm here on a Mac, so I'm going to open up the terminal. So the terminal is basically this very simple interface that most of the operating systems that we use, like Windows, Mac, Linux, Unix, and so forth, have this kind of like very simple terminal or interface, which means that what you do through the terminal is you write commands. So it's basically a text interface. You type something like, I don't know, ls, which is short for list, and this will list all the files in the folder. You have like cd, which is change directory. So let me go to the directory that I'm going to be doing my tests with Git. So I'm using cd change directory and going to the folder downloads, the folder compendium, live share, and then I have this folder. So this command through the terminal will change to this sub directory. You will see that I'm right now in the intro to Git subdirectory. And if I run ls, it will list all the files in this folder. You'll see there's nothing there because if I go to the to my Finder, to like the graphical user interface of the operating system, this is like the folder view. In here, there's nothing. If I create a folder, so most of the times we use the graphical user interface, like on Windows, we just use this drag and drop interface. So I just created a folder, which means that if I now go and type ls, I will see the folder through the terminal. So basically, this is like a more like a simplistic, more simple interface, more simple way to view the file system, and also run commands on our computer. But all these are text commands. There's no drag and drop. You can copy and paste some of the text here, but mainly we just interact through writing commands. This interface has quite a few terms. So you will find it, people refer to it as the terminal, as console, as a command prompt, sometimes as a shell. So these are basically different terms related to the same, basically the same thing, this text interface that we can use to instruct the computer to do things, and also to run several programs that are available only as text commands, only through the terminal. One command that I will use.
Sorry,
Yes,
Kostas.
sure.
Kevin has joined. Oh, he left. Okay.
Thank you. If I run the command clear, it will clear the terminal view, so I can keep writing commands, but clear this cluttering. Now I'm going to put my terminal here on the right side, and let me clear once again. And I'm in the intro to Git directory. So the folder here, or the directory, you will see here, will be accessed through the terminal. For example, if I want to delete this folder, I can either go through the drag and drop interface. I can select, right click, and say move to trash, move to bin. So that will delete or move the this folder to the bin. But I can also run a command in the terminal called rm, short for remove. And no, basically it's rmdir, so remove the directory. All the terminal commands are really short. We don't want to type too many characters. And I can say test, and this will delete the folder. So now you can see that all the commands are reflected on the actual file system on my system. So I will keep this terminal on the right side of my screen. This will be the main folder. This is just a directory called intro to Git where I'm going to be playing with Git. And also, I think I will be using I will open another terminal. You can open up as many terminals as you want, and you can run various commands through these different terminals. I'm going to run now a command, not going to go deep into this. This is basically a command I use to open up a kind of like a local offline private chat GPT. So basically, you will see in a bit that I run an open source GPT model. This is an application that you can install on your system, and basically what it does is it opens up an interface, a chat interface, and you can chat with a local AI system. So instead of connecting to ChatGPT, I can say, what is Git? And then it will give me some information. Now, there is a video. We have a video about how to install and run this Olama software on your system. I'm not going to go into this. In your case, you can just use ChatGPT, which is an AI tool that will help you in explaining terms or help you with commands that we will learn or any other task. So this is just like a quick, let's say, way for me to chat with some AI tool so that it can help me from time to time to remember some commands or tell me what to do next if there is an error and stuff like that. So you can replace this with ChatGPT on your side, or you can check our videos and see how you can install and run this AI assistant on your system. So folder, the main folder, the terminal, and another terminal for chatting with this model so that we can get some AI help. These days, the AI models are really, really helpful, especially for beginners. So that's my setup. But before diving into Git and the Git commands, I want to give you a broad overview of what Git is about. So before going to the Git internals, I'm going to open up 3 applications. So I will create a Google Doc, and I can use this shortcut, this doc.new on my browser, and it would basically create a new Google document. I also have an extension that will turn this into dark mode. So basically, I just created a Google document. Let's say, I don't know, like test doc. The Google Doc, if you don't already know, it's kind of like the software provided by Google, which is kind of like something like Microsoft Word. It's basically an editor, a tool that we use to write documents, to create text documents. And in a bit, I will explain why we'll go through this. I will also open up another Google service called Google Spreadsheet. There's another shortcut that will help me create really quickly a new Google Spreadsheet. So it's sheet.new. And this will just create an empty spreadsheet. I will name this, let's say, test spreadsheet. And then I will also open up another software, which is called Photopea. We will share all these links afterwards. So Photopea is a website that you can use to edit photographs. So this is kind of like the free web version of Photoshop. You know Photoshop, which is a video editing tool. Photopea is a thing that you can just you don't have to log in. You just open it on your browser, and you can basically edit images or draw or do things that you can do with Photoshop, and it's completely free. The only annoying part is these advertisements. So just basic stuff. Let me pick a color. Think of this as a web Photoshop. Now, why did I open these 3 applications? Because I want to explain, and let me also turn this, let me turn this into like a black, dark background. Because I want to explain a very important concept that will help you understand the Git philosophy, which is the concept that I'm about to explain is state. So what is state? In software, state is, broadly speaking, when we have something like a software or a program or an application that, let's say, is in a particular shape or form or displays some sort of like output. Um, Basically, let me go to the definition of the word state. So I will go to Google and type define state, and see like the actual definition of the English word, which I think is going to help us understand state in software. So state, broadly speaking, in like English, is the particular condition that someone or something is in at a specific time. So if we think about in software, when I'm talking about the state in software and in a particular application, like for example the Google Doc, when I see an empty document, I can say that this Google Doc is the state of this Google document at this point is a blank page. So the state is how this document looks at a particular point in time. If I start typing something on my document, I'm actually changing or transitioning to a different state. So the previous state, which was a blank document, is now a document that contains the word "Hello World" and the dot. So an application might start in a particular state, like a blank page, and then either through the user interaction or through some other event, maybe some system event, the state of the application changes and we see something different. So this, like in simple terms, is the state, the concept of state. You have something that appears in a particular form or shape or in a way, and then the state changes and you see something different. So now we'll go to another state. Welcome to Git intro. So I went from the state of a blank page to the state of the particular document that says "Hello World," and also I moved to now a different state, which is contains the "Hello World" and "Welcome to Git." I will go back to this document because I also want to show you two more examples to understand how state relates to software. So this is how state relates to the Google Doc. If I go here to my my Google spreadsheet, I can type like an Excel column. I will say this is the first name column, this is the last name, and then I start typing, some data. Once again, we have a software and application that starts in what we call an initial state, which is basically in this case it's like an empty spreadsheet. It's not like a blank screen because it contains these empty cells, these empty rows and columns, but no data appears in this cell. So we say that this is the initial state of the spreadsheet application is a few columns, as you can see here, and a few rows that contain no data. By typing into the cells, I transitioned from the blank state to a state which contains two columns and one row with a name. Last example of how state relates to another application, I have this, let me just delete everything. Sorry. So in this case, for example, the initial state of this Photopea editing tool is a blank black screen or a black canvas. So this is the initial state, and if I start drawing, I switch from the dark black initial state to these two lines, the two white lines. And then I can continue drawing. But let me restart this just to make it a little bit simpler. So I will keep it white for now. So I start with a blank white screen. I draw two lines, then I draw two more lines, then I draw two diagonal lines, and then let's say I start drawing hello. So we started another application, and once again, the state of this application, the initial state was a blank white document or canvas. I continued by drawing two lines, then changed the state to kind of like four lines, like that make up a square, then one diagonal line, one more diagonal line, and then the hello. So the state transitioned from a blank screen to some lines, some more sketches, and we find ourselves in this like latest state, which is kind of like this, I don't know, like envelope with a hello. So this is a very important term in software state, the state. Now, why did I use all these three applications? Because now I want to show you some really important concept. The next concept is that whenever the state changes, all of these three applications keep a history of the previous states. So on the Google Docs, if I go to this icon, you will see that I have a version history. So basically, it says that on September 27 at 1724, I started by writing something. And then if I open this up, I made some changes at 1728 and then 1729. So 29. So for every state change, this application keeps track of the state changes, and it gives this to me as something that is called in this particular software version history. This is probably the most important concept that is related with Git. So version history is this series of snapshots, this series of state changes across this application. And the cool thing about Google Docs is that I can go back in time. I can go back to 27th of December at 1724, which is the initial state, of course, a blank document. I can click on the next state change on 1728, which is basically hello world, and then I can go to the latest one, which is the latest state, which is at 1729, which consists the hello world and the welcome to Git.
Aynen. Ne, tamam yine laf yok hareketi otobüs durağına bıraktılar. Lafın bir otobüs.
I'm not sure, Asteris, if you can mute some of the participants. There's some noise. So we can switch between different like times and probably dates, and we can see what the state was at a particular point in time. This is like, I would say, the most important term and concept when we will go into Git. State changes in an application, and then we keep track of these changes, and then we can go back and forth through this version history. Quickly, I will go to the spreadsheet, which is basically the same. We have another version history. Now it's a little bit simpler because we start with a blank spreadsheet, and then we change, and at 1730, I just add these two, I fill in these cells. So another state tracking mechanism, this is also called version history in the Google spreadsheet. And of course, we can go back and forth. In both of these applications, we can also rename these changes. So instead of saying 27 of September 1525, I can say name this version initial state, and then I will name this let's say first entry. And if I now add another entry, so I will go back, I will switch from the version history to the spreadsheet, and I can add asterisk, and I will probably have another state or another snapshot in the version history that will contain the, as you can see, the introduction of a new row. The cool thing about this software, both the Google Docs and the spreadsheet, is that as I move from a different snapshot to another one, let me rename this one. it highlights the parts of the document that changed. So from going from a blank state to the first entry, you will see that the green highlighted areas are the parts of the spreadsheet that changed. So previously there was nothing here, and now the green means that an addition happened. Something was added to these 4 cells. And if I go to the next state, you will see that it highlights just the 2 cells below row 2 that I just introduced. It's the same with Google Doc history. You will see blank state, moving on to an additional line saying hello world, and then adding a space here, a new line, and a welcome to Git intro. So they're really nice because you can also see the difference between different state changes. Also crucially important for a Git. And last example, this software, the Photopy, automatically keeps track of the state changes. And you can find this in a tab here called History. This is the latest state, and I can go back in time. I can go, as you can see, back in time, all the way up to the first initial state, which is when I opened the file and I came across this blank image. And I can move forward, kind of like recreating my process, the steps that I took to finally arrive at this state. And the cool thing about all these 3 tools is that not only I can go back in time in a sequential or in a step-by-step manner, but I can quickly jump from the latest state to, let's say, somewhere here. So I just skipped, I don't know, 5 or 6 steps, and then I went back in time. Now, this is very important. This is why we see this version tracking, this history in all the software. Most of the software that we use have this sort of tracking of the steps that you take and the state that changes through the application. The most obvious, the most common way that we see this history, this tracking mechanism in almost all the applications that we use is through the undo redo file. I think if you open up 100 applications and you go into the menu, sometimes called file or edit, depending on the application, you will find these 2 commands, undo, redo. Undo means go 1 step back. So you change something and then you want to go 1 step back. And you can keep going depending on the application and how long the state or the tracking is in its application. You can go back in time by saying undo, 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 and then you go back 1 step, 1 step. So in this case, it's split into step forward and step backwards. So I can go backward, as you can see. Also I can go step forward. So this is the redo. So undo something that you did, or redo and go 1 step further. And this is important because we as humans, we make mistakes all the time, which is a good thing. You accidentally type something. If I go here, this happened to me. I select some text and then I accidentally press a key and it's deleted. So how can I go back? I can go here and I can press undo. So that's really crucial. And another thing that's really helpful in this history tracking is that not only you can go back in time and restore some information or some data that was deleted by mistake, but you can also go back in time and check and compare how the text or the image or the spreadsheet looked 1 month ago. Not because you want the data, not because you want to bring this data forward and replace the current state with that previous data, but because you want to see, for example, how many students or how many participants, let's say in a session, were 1 week before or 1 hour before. So this version history helps you, go back in time, check something, and evaluate, the situation, the condition, or what's happening, depending, of course, on the tool. So this is kind of like a broad overview of the very important concept that we need for today's session, which is state. So software, state in software is how an application looks like at a particular point in time. The state changes, so we change things, and the state changes, so we add more text, we delete text, we draw something, we erase something from the screen, and the state changes. So what we see on the screen or what the app is displaying changes over time. There's the version history mechanism, which basically keeps track of all these changes and gives us like this nice linear kind of like history list, so we can see when things changed and what they looked like. And this is, I would say, the most important concepts to understand before we switch to Git and see how Git really relates with these concepts: state changes, and the version history. I will pause in here for a bit to answer any questions. So if you have any questions or comments or something that you can point out or suggest, let me know. I will continue. Asteris will facilitate the conversation. So if you have a question, just please raise your hand, open your microphone, use the chat, and Asteris will stop me, and we will have a discussion. It's really important that we go through this together. So let me switch now to Git, but instead of immediately switching to the Git, to the terminal, and start writing Git commands, I will draw some things that will help you understand how Git works on a very basic level. Let me switch to a diagram. So I will start with like this. No, let me zoom out. So I will use some drawings, and that will help you. So this is our computer, and I think I will turn this off again. So this is okay. This is a computer. You will see. Inside our computer, we have like a disk drive, and inside the disk drive, we have files and folders. So I will create another like box. Let me give it a different. So inside our computer, we have files and folders, which is where we store our data: images, text, music, video, whatever, applications. So this is like the storage space. Every computer has this file system, and we write things. Okay. I think I will make this a little bit smaller. And inside the folder, of course, we have files. So let me create just a bunch of files. Let's say we have a txt, a text file. I'll call it. Let me make this a bit smaller. So you create files, and these files are basically some data. So I will have story. Let me see. I will have another one called temp, short for temporary. Some text file that contains some, I don't know, temporary information, some notes, and then another one which is called, let's say, secret. Okay, so this is like a folder, and you create or you copy and you paste or you download files. In this case, I'm just depicting 3 text files that are found in a particular folder. In this case, because I'm going to work with a folder called intro to Git. Going to also put the name here, make it a little bit smaller. Now, where does Git come into the picture? So remember, Google Word, Google Spreadsheet, Photopy, are applications that let you draw or write a document or edit the document or edit a spreadsheet, and they keep track of state changes, and then you can go back in time. So Git basically is kind of like a super tool that lets you add this kind of ability, track state changes, and then go back in history on any folder on your system. So basically, Git is a super tool which allows you to have an undo redo in any part of your disk drive. So that's like Git on a very basic level. Git is a program. So let me go here. I have like two icons I'm going to use. So I will say this is, you probably seen the internet depicted as a cloud. And then I also have the logo for Git, which is somewhere here. Here's the Git logo. So Git is an application. It's a program that you download from the internet. So Git, and we have Git here. So it's a program. Git is a software, is a program that you download from the internet. Let me just draw this in a little bit differently. So you download this from the internet and into your computer. So you go on a website which is called Git SCM. SCM. This is the official page. We will paste all these links. You go to git-scm.com. You find your download link. This says download for Mac. If you open it on Windows or Linux, you will see different pattern. It's available on all platforms. You download this, you go through the process of installing it, and you have Git installed on your system. Okay, so you download, and then you can use this. You have it on your machine. I already went through this process, downloaded Git, and I have Git on my machine. Now, the thing about Git is that in contrast to other software like Photoshop or Excel or, I don't know, a game that you download or maybe like a code editor, it's a program that runs through the terminal. There's no application that you can double click and see some kind of like graphical user interface or Git. By default, the program that we download is only available through the terminal. So if you download and install Git on your machine, you will open your terminal. And to actually make sure that you have Git installed, you'll have to run git dash version. If you see something on your screen, this is the version of Git that I have installed. It's a little bit older because I installed Git quite a few years ago. But if you see this, it means that you have Git installed on your system. It is available as a command through the terminal, and you can run Git, and you can follow with the rest of the commands that will show. Now, if for some reason you don't have Git installed or the installation procedure was not successful, you will see something like an error. So, for example, if I try some command that doesn't exist, whatever. So if you run Git and it's not installed, you will see something like this: command not found. In my case, you can see there's this Z said. Don't worry about this. If you're on a different system, you will see an error that will say command not found or error, but basically you will see that Git is not installed. In that case, you have to go through the procedure again and maybe troubleshoot, ask some questions, or Google for what happened and make sure that Git is installed. So I have Git installed. If you type Git, you will see like a big documentation, like a help screen that will show you some of the available commands and what you can do. I will clear this for now and move forward. So I have Git on my system. I can open up a terminal and run Git commands. So let's see how we can, Git allows us to take a folder and provide the ability to track changes over time, and then have a version history so that we can go back in time. Now, let me know. You can open up your microphones or you can ask questions. In the meantime, I'm going to prepare for the next steps. So we went through. I think we saw. Okay. Yeah, one thing that I need to mention is that in this, let's say, in this overview, this is my computer or this is your computer, so you can download Git and run it on your computer, on your local machine, as we say. But Git can also be installed on any computer, even on a server. So a server is basically a computer that is kind of like a remote computer, a computer that is um, connected to the internet and it's available to somewhere on the internet or on the cloud.
Oh,
Um, was there a question? Um, so server is basically a computer that is somewhere like in a remote place in a company that hosts like these computers and you can connect to these computers called servers, but it's basically the same
sorry,
thing.
Costa.
Yeah.
We have a new member join, Paris Haralambidis. Maybe you want to do a quick recap. I don't know.
Uh, Really quickly, we're just going through Git. Basically, a small recap. So Git is a software, a program that we can download, and then we install on our system, on a computer, on any computer, either our own laptop, our own computer, our desktop, or whatever, but also on a server. And it allows us to keep a track of changes that happen in a particular folder or folders. So up until now, this is just a broad, high-level overview of how Git fits into the picture of your local machine. We haven't seen any commands yet, apart from the Git dash version. So now I'm about to show you how Git can enable this ability to track changes. Before going into this step, I'm going to show you what happens if you don't use Git. Let me see. We covered this. Okay. Now, if I go on this folder and I start, let's say, making changes, so I will create a new folder called temporary, and then another folder called, diagrams or whatever. And then I can also create, let's say, text files. Now, on my Mac, I'm not sure I can create a new text file, so I'm going to use a terminal command that allows you to create files through the terminal. So this command is called tats. This will create a file, a simple text file. So I'm going to create a story.txt. You'll see it immediately displayed on my Finder. So it actually creates a file, and I can find it through the file system. I will create another one called temp.txt, and another one called was secret.txt. Now, if you don't have Git like enabled on a particular folder, in this case, this folder is called intro to Git. You can change anything you like. For example, I can delete this folder. Let's delete also this folder. I can open up this text file, add something, hello world, save, close, open up this one, temporary, click save, close. And of course, if I open it up, you'll see the changes here and the changes here. And I go back here, I, like delete this and write something else, literally something else. And in here, I delete. Okay. Now, this is usually how we work with our computers, right? We change things, we delete files, we add and update documents, or you know, do some changes. The bad thing about this is that once you made some changes to a file, you can not really go back. Like for example, in here, if this wasn't like if the previous state of this document wasn't like hello world, which is easy to remember, let's say, or at least for now, it would be impossible for me to go back in time and remember what was the previous sentence or what was the previous chapter. Maybe this is like a huge document. So without a version control system like Git, the changes that you make to your file system, to your folders are, let's say, irreversible. The only thing that you have in on your file system is that you can delete something, you can move it into the trash bin, trash can, recycle bin, whatever it's called, on various operating systems, and then you can just restore it. So I think mostly it's about this thing. If you move these files to the recycle bin and you empty the recycle bin, it's gone. There's no way going back. Okay, it's really hard. It's not impossible, but it's really hard. So by default, all the changes that I make here are, one thing, and then I lose the last state. The things that were before in this file or this folder are not. I will not be able like to restore them. So Git has this magic ability to keep track of changes and helps us like go back in time. So instead of making these changes and then uh, um, making it impossible to go back, or losing the previous changes, Git helps us track of these changes and store them in some kind of a version history. So I'm going to remove everything from these files so that I start with uh, with three empty files. And I'm going to enable, I'm going to let Git start tracking changes in this repository. So we have here, let me zoom in a bit. So this is a simple folder, okay? Let me go back here to go to the, okay, so this is a simple folder, and this kind of like let you make changes, but the changes that you make are, let's say, irreversible. They're destructive. You make some changes and then you lose the previous change. So what Git does is it magically wraps your folder. Let's say this is something just to imagine. It doesn't actually happen, but basically it puts this, let's say, magic layer around your folder. Um, and instead of dealing with a normal folder and files, being deleted, removed, changed, and so forth, it gives you the ability to track changes. So when you say to Git, this folder, I want you like to track change. I want you to make this so that the things that I do will be stored in some history. So if you go back here, we want this thing, this version history, like in Google Docs, or this version history in spreadsheet, or this history in Photopea, to be available on our file system, on our folder. Okay, so this is what Git does. So how can you tell Git to take a folder and turn it into a magic, let's say, folder, special kind of folder, which is called a Git repository. So this kind of like, let's say, magic Git layer, which kind of like works on a particular folder or folders. You can have as many folders as you want to become a Git repository. This kind of like Git repository term means that a simple folder is turned now into a folder that has these capabilities of tracking changes across time. I think there might be a question, Asteris.
No, it was me because my
Okay.
screen joined. I didn't want to interrupt you.
So this is like what Git does. It takes a simple folder and turn it into like a super folder, or a folder with special capabilities. And the technical term for this, let's say, super folder is Git repository. So let me just write it, super folder. Okay, this is my term. So the official is Git repository. So how can we take one folder and turn it into a super folder? So basically, there's a command for that, which is called git init. And so you tell Git, you run a command through Git, and you say, okay, I want you to, no, not this one. I want you to, also not this one. I want you to turn this folder.
Sorry, Costas.
Mhm.
Because Nesrine just joined and she's feeling like a little bit lost. Maybe you could also do a quick recap for her. Or
Sorry, I don't
I
want to interrupt anything here. Hello, Costa. Hello,
hello,
Asteris,
Ron.
and other guys. I thought that our appointment is for 6. I'm trying to follow, but I don't. I don't
Okay.
know.
Yeah. So don't worry, we are recording, so there will be like we will
Perfect.
upload it, so there will be time.
Okay.
Just a quick recap. Okay, I will try to make it as quick as possible. So basically, we were talking about this tool called Git. Is a tool that you download and you install on your system, and it's made available as a command through your terminal. So you just open up a terminal and you run Git and some parameters. And this basically takes a folder on your system where you keep some files, and it tracks of the changes that happen in that folder. So when you delete something, when you change something, these files, Git tracks of these changes, and you can have a history of changes. So instead of changing something like deleting or updating a file or changing some text and then losing the previous state, the previous state of that folder or files, uh, Git lets you keep track of the previous steps, so you can go back in time. So that's roughly what I'm trying to explain this as a general overview of Git. Uh, Follow and we'll have like the opportunity to rewatch from the beginning. Um, I will try to pause at each point and do a small recap and also maybe answer questions. Um, so we have our folder, and the way that we turn this folder, this red folder, into a super folder, a Git repository, is by running the command git init. So let me do that. And before continuing, I'm going to type clear to clear the console. I'm going to run a command on Mac, which basically allows you to show some of the hidden files. So in your file system, you probably know or don't know it, but when you open up a folder, you see some files. But apart from these files that are visible, you also have certain files that are called hidden files or system files. So in order to protect the user from accidentally deleting or even seeing some files that are important for the system, but they might by accidentally get deleted, or there are files that the user shouldn't change, that your file system, your computer, hides these files. Now, I will run a command on my Mac to actually see these invisible files. Let me see if I can open up like yeah, okay. So here's another folder just to show you. It's called LiveShare, and I have like I have 7 folders. Okay, so by default these are visible folders, and I don't have any files here, but I could drop in a file. And these are the normal files and folders that you can see and work with in your file system. But there's something that we cannot see, something that's invisible. So in this folder, apart from these 7 folders, there's a hidden thing, which I'm going to run some command on my keyboard. It's Command Shift dot for my Mac. We will share these shortcuts afterwards. So basically what you see when I press this command is there's this folder, which is kind of like a little bit dim colored. So it's not the same color as this one. So this is like a hidden folder. So by default, your system, your operating system, either Windows or Linux or Mac, will hide these folders because they're not there for you. They're there for the system. you shouldn't be interfering or doing things with these files or folders. So these kind of files or folders are hidden by default. So if I go back to my normal mode, I don't see anything, which means that it protects, the system protects me from accidentally removing something that will be important. But for this one, I'm going to turn into the invisible or visible mode, so we can also see the invisible files and folders. Let me quickly run this on my machine. So on my Mac, I pressed Command Shift F, Command Shift and dot. So how can I show hidden folders on my Mac? And I think most of the times it does a really good job. It says probably Command Shift and dot is the correct one. I went to sleep. Okay, it's a little bit too much. I want okay. General. Let me try another one. Just in one sentence. Maybe this time it's okay. We can go through Finder. Preferences. There's a way. Here's the shortcut. No, it's not the shortcut, but we can find the shortcut. If I run this command for Windows, remember you can ask these questions on ChatGPT. On Windows, you can go to File Explorer and show hidden items. So you can Google or go to ChatGPT. There's on all systems there's this option to show the hidden folders. You can also say how. Let's say give me the keyboard shortcut. So there's always a keyboard shortcut. In Windows, it says Windows R and R. Let's say that, let me see if on Mac. AI systems sometimes do mistakes. So Command Shift dot. So this is the period. This is the correct command. Hopefully it does a good job in Windows. You can try it later. You can ask these commands on ChatGPT. So now if there's a hidden folder in or file in here, I will see it on my folder. Why did I do this? Because in order to turn this folder into a super folder, into a Git repository, I will run the command git init. So by default, this is a simple folder. I will run git init, and what I get back is this output. It says it initialized an empty Git repository in. This is the path to my folder. So this is where the folder happens to be found on my file system. It's in the folders users, Costa 6, downloads, Compendium, blah, blah, blah. And now this became a Git repository. So instead of this being a simple folder, it's actually a Git repository. When you want to turn a simple folder into a Git repository, you have to run this git init command just once, okay? You never have to run this command again. This is a one-time command. And you will see that the way that Git initializes this folder as a Git repository is by creating this hidden folder called .git. This is kind of like the magic behind Git. This is a hidden folder that kind of like turns this folder or any folder into a Git repository. So if you can see your hidden files and you can see this .git in one of your folders, it means that at some point you or someone, maybe this is something that you downloaded from the internet, this is a Git repository. This is not a simple folder. It has Git, and Git is tracking changes on this folder. So git init, one-time command, and your folder goes from this simple, let's say, from the simple state of being like a simple folder, it now is a Git repository. So we have given special superpowers to this folder. The next command I'm going to show you, let me go here, sorry, my folder and my commands, and let me check my list. Meanwhile, let me know if there are questions. Okay. The next command, and I will provide a list of all the commands that I run in the order that I show them. I will share a list with everything that I type, so you can check it afterward, but you can also rewatch the video. The next command that's really important is once you have a Git repository, you can run one of the commands that you will be running a lot. So Git status is basically showing you a status of this particular Git repository or folder. And you will see some output like this. Now, we will go through this line by line to actually understand what's happening. But if you have if you run Git status on a folder that's initialized with Git init, and it's a Git repository, you will get some output that looks like this. If you run this on a folder that is not a Git repository, it's a simple folder. So let me go back to let me clear the console and let me go back to this, let's say, Docker. So now I'm changing directory and I'm going back to the parent directory. So now I'm inside the intro to Git folder.
Sorry, Kostas, there is a question from Nesreen.
Yeah.
If you can look in the chat.
Yep, give me a second. What can help us to use both terminal app with Git account? So a Git account, just quickly, we haven't covered. So
I'm following you, Costa. Thank you.
Yeah, you're welcome. So there's no such thing as a Git account. There's a GitHub account. So Git is a program that we're using so far. We haven't covered GitHub. GitHub is a service where you can sign in, you can register for an account. So it's complementary to Git. Okay, so we're now looking at the Git, the program. We haven't opened up an account or haven't touched or talked about GitHub. This is something that we talk about at the end. So I keep this question for the end. GitHub is another thing. It's related with Git, but it's a service, it's an online service that you register for an account, just like Gmail. So we will cover that at the end. For now, think that Git is a program. There's no account. That you don't need to open an account. You just download Git and you run it on your machine. So two different things. So thanks for the question. So now, if I want to go back to the parent directory and then go into the Docker directory, I can run cd, short for change directory. This is the shortcut in terminal for the parent directory. So from Git, so I'm not sure you can see it here, but I'm inside intro to Git. If I want to go to the parent directory, which contains this this intro to Git directory, this is my live share. I will type these two dots, and now I'm back to the parent directory, which is live share. Intro to Git, the parent directory which calls intro to Git is live share. So now I'm into live share, and I'm going to change into the Docker. So now it's like I did this. I'm here, intro to Git. I go to the parent directory, and I go into Docker. With a terminal, you can go to the parent directory like this, and then change to the Docker directory like this. So exactly the same things that you can do through your operating system, through the visual, let's say, environment or interface. You can do it through commands. So right now I'm in here in Docker, and as you can see, there is no .git folder, which means this is a plain folder. It's not a Git folder. And if I run git status, you will see different methods. It says fatal, means like an important error. This is not a Git repository. So if I try to run git status to check the status of a Git repository, if the folder that I'm currently in is not a Git repository, I will get this message. If this is a Git repository, I will see different message, the one that we saw earlier. So if I do git init, what will happen? Git will initialize this folder as a Git repository. A .git folder will be created here. And if I now run git status, you will see that I get a different response. So it didn't give me a fatal error. It now sees that this is a Git repository because of this .git folder. And I see some information that I will go through. So this is how Git kind of like initializes a folder, is by creating a .git hidden folder. You can see it only if you enable hidden folders on your system. And if I remove this manually, if I delete, if I move to bin, or I can run a command here, you will see that if I run, let me run git status again. So the previous output of git status was this one. Now, since I removed the .git, it's now back to a normal folder. So if you remove the .git, Git is gone. Now you're back to a normal folder. There's nothing magical. There's nothing about superpowers in this folder. So you're back to a normal folder that you can make changes, but you can lose these changes. Now there's nothing there to track changes. So the .git folder is important. And as you can see, it's important that it's hidden, because if you accidentally remove the .git, you lose everything, all the history that you have been tracking. So that's why these kind of folders are hidden by default, so you don't accidentally do some, some stuff like removing the folder. I will go back to my parent directory and then back to intro to Git through my Finder here, my Explorer view, let's say. And I will clear my terminal, go back to the parent, and then go back to intro to Git. Now, through the terminal, you can either type the full command or the full folder name, but there's also a nice thing that if you type the first few characters and you press tab on your keyboard, it automatically fills the rest of the folder or the file name. So now I'm back to intro to Git. So quick recap and questions if you have. We took a folder, a simple folder. We ran git init. Git created this .git hidden folder. We were able to see it because we turned hidden folders on. And now by running git status, we will see some output that I'm going to explain next. Let me know if there are other parts that I might have missed, or something that you want to discuss or point out before we continue. Okay, moving on, but feel free to interrupt me at any point. So let's go line by line, like to this on this like output. I'm going to try something here that you probably might want to try with something like ChatGPT. So, for example, if you don't understand something, let me find something that's easy. So, let's say you're a beginner in Git and you run Git status and you see all these things that I'm going to explain, but you're on your own. So you can go to ChatGPT and you can say something like, I just ran Git status on a Git repository, and I see untracked files. What does this mean exactly? So ChatGPT is really powerful, it's really smart these days, so it can help you and it give you a brief description of what happens. So break down the output in small steps, and you can let ChatGPT explain its line in the output. So, for example, you can say, "What does on branch main mean?" or "No commits yet," and it will probably do a good job. I'm not using ChatGPT. Let's see what happens. Means that there are files on. So it gives me like a very, very detailed overview. I won't be sticking with this. I'm just going to explain, but on your case, you can you can run this through ChatGPT and get some response. If this is too intimidating for you, you can try things like try to be imaginative. So explain this like I am 5. Might sound silly, but it's explain this. You will see that it helps you. So let's see what happens if we say. So as you can see, it's going through a very more simpler like explanation. It says when you run git status is like asking the git box to tell what's going on with all the puzzle pieces. The message untracked files means something. So try to be imaginative and try some things that will let ChatGPT break things down in a simpler terminology, and also follow up with questions like, I didn't understand this, please explain this, I want another explanation. So ChatGPT these days can help you just come up with more questions. I will just explain things line by line. So there's one thing that's really different, that's make Git different from all these applications that I showed you earlier, like a Google Doc or Photopea or Google Spreadsheet, or most of the applications that keep track of changes and give you this version history, do this on an automatic basis, meaning that they have some sort of like mechanism that takes snapshots of your application at different, let's say, intervals or different points in time or different interactions, and it automatically creates this version history based on let's say, character you typed, or maybe a line that you typed, or maybe that you pressed enter. Depending on the application, the snapshots, the state changes will become available in a version history in some automatic way. Git gives you total control over what you want to track, when, and how. So Git is not just tracking everything and keeping and storing these changes in a history. By default, it tracks nothing. So it gives you total control, and it says, I will enable this Git repository, but I will track nothing on this repository unless you give me a strict command, a strict instruction on what exactly you want me to track. I will just do nothing. So think of Git as now being like a detective in your folder that's just sitting there on the side doing nothing. It waits for you to instruct it to track some particular parts of your folder. So by default, Git tracks nothing. That's important, which makes more sense of what we see here. And you have to get explicit instructions on what exactly to track. So think of this as like a detective. There's the folder is like a, let's say, a big room with full of people, and you want this detective to track someone, to find some more information or track a very specific person. You don't want this detective to start tracking everyone. You say, there's someone that looks suspicious in this room. I want you to track what this guy is doing. Maybe there's some danger. So that's how Git works. You have to be very explicit on what exactly to track. So I'm going to skip the first line. There are two like terms here, branch and main. I will go through them in a bit. There's also another term called commit, which I'm going to skip for now. We will see in a bit. The part I'm going to focus on now and explain in this output is these lines. So it says they're untracked files. There's a description here. I will go through it, and basically these lines say that you have a Git repository. You have some files that I do not track. So Git just comes back to you and says, I see a secret txt, a temp, and a story. These are the three files I see in this room, but I'm not tracking it. So untracked means that whatever you do to these files, I will ignore them. I will not track anything. If you remove them, if you delete them, if you change them, it's up to you. You will lose your changes. So I'm not tracking anything. So at this point in time, these files are what we called untracked. Okay, so let's make this. I don't know. We'll put this in brackets. because files in a Git repository are found in three different states, three different conditions. One of them is untracked. So let me put this like this, and I will create a list with the three different states that a file can be found inside Git. So inside Git, files can be untracked, A. And if you want to say to Git, hey, this guy is really important for me. I want you to track this file. So if you want Git to start tracking this file and ignore all the rest, so I will put like something like a copy, but it's not exactly a copy. So if you want Git to start tracking a particular file, you will use a command called git add. So basically what you're saying to Git is, hey, take this file and pay close attention to it, okay? And what Git does, and let me write the full command. So git add story txt. So this is like, I want you to track like this file, okay? Don't ignore it. Start tracking whatever it does. There's a person in the room that looks suspicious. Please pay close attention to this guy because he might do something bad, you know. So Git now starts tracking this guy here, this file. Let me put kind of like there's an icon. So now here is the detective paying close attention to your files. So this is what git add is doing. You say to Git, pay close attention to this file. What Git does when you add this command is it creates like a copy of this file, sort of like a copy, in an area or in an area that it's called staging. So staging area. So this blue thing here, kind of like a special room if you want, or a special, let's say, area, where Git takes a snapshot of the file that you instructed it to, and it says, okay, I will keep track of the current state of this file, and I will remember it because I want to pay close attention to the file that you just instructed me to keep track of. So git add story makes a copy, takes a snapshot of a file or a copy, if you will, put this into a staging area, and Git now will pay close attention to this file. The rest of the files, txt, temp.txt, and secret, will be ignored. They will be there, but they will be untracked. This file now is in the second condition, which is called tracked. So now we have Git tracking this file. These two are untracked. So these, let's say, now are untracked. But this one became tracked. Now Git is tracking. Okay. So once again, Git like disregards everything that you put in a folder. It says, okay, I'm here to help you, but let me know if you want me to track something. And you have to explicitly say, track this file, these files, folders, whatever. And you can either run this git add command with a simple file name or with other options. So you can move, let's say, all of the files in the staging area and have Git tracking all of them. So let me go back to my terminal and do just that. So here's the output before we started tracking. 3 files in our folder, all of them are untracked. So let me say git add, I said story. Okay, we don't see any output, but we don't see any error as well, which means that probably everything went well. Now I'm going to run the git status command again to see what just happened. So now we see the previous output. Sorry, the previous output was just looked like this. And now there's a slightly different output. So let's see what remained the same, and let's see what changed. I will keep you on the screen to like look at the differences, and I will go back to my notes to see what I need to cover next. So we went through this. Untracked, tracked. Okay. So what remained the same is this this untracked file section contains the secret and the temp, because we never added these two files to the staging area. We never said git add secret or git add temp. So these remain untracked. Git will just forget about them. It says, I don't know what will happen to them. I will just ignore them. But this one, the file that we run git add story, is now in a different part of the output. It says changes to be committed, new file story.txt. So I will ignore this one. We're going to go through them step by step. Now there is a file that was previously untracked, and now it is in the track state. Now Git is took a snapshot and it's tracking this file. So this is this green color also means that Git is now aware that the story.txt file is in a particular state at this point. So now it's tracking changes. So we have this tracked file. Now changes to be committed. Once again, we have this commits, committed. I'm going to explain it in a bit. Don't worry about this. So we just started tracking this story.txt. Let me see. Commits. Let's see. Okay, so now what I'm going to do is I'm going to make some changes to the story.txt. So the story.txt was in a blank state, in an initial state where the document was empty. And I'm going to add hello world. No, I'm going to add, let's say, change A. Okay, so I'm going to add some arbitrary, well, random text here. So I'm changing the file and going from a blank document to this state. Now let's see what happened when I run the git status command. So once again, we need to compare the previous output with the next output. Now there's a lot of things going on in here. So we have these untracked files. So I will temporarily, let me see if I can measure. I will move these files to a different folder for now. And I will run git status just to get rid of some of the the extra output. So let me just do this again. So I will go back to a blank document. So going a few steps back, that's just to see. So now the output is simpler. So we have this untracked file, the story. We ran git add story.txt, so we started tracking, and we see it in this green color, and there is changes to be committed. And now I say change A and run git status to see a less cluttered, let's say, output. So now what we see that's new, that's different from the previous output, is this here, this part here. So let me go back to the diagram to explain what happened here as we moved along, and then make more sense of this output, because Git is intimidating. At first, it's kind of like looks very cryptic, and it's very difficult to understand what it means. So we were in this case, in this state where story.txt was an untracked file, right? We use git add, and this contained like, let me put this. So this was like this was like an empty document. Okay, so this is like these are the contents of the file. Okay, so it was like just an empty file. We said to git, I want you to track this file. So when we said git add story.txt, git took a copy of the story.txt. It put it inside the staging area, which means that this snapshot contained the state of that file at that particular point in time, which means a blank document. So the snapshot that Git took when we ran git add was a story.txt file that contained nothing at all. Okay, so think of git add as the detective taking a photograph. So at a particular point in time, the detective is tracking a person. They're like, I don't know, coming out of a car or entering a building. They take a photograph, and that photograph is kind of like a frozen point in time, right? The thing that person that they're tracking actually did at a particular point in time, entering a building. In our case, is a file that contains nothing. So it took a snapshot, it took a photograph, and here it holds this snapshot. So staging area is kind of like the you can think of it as the snapshot area. Our detective is taking snapshots of the suspect or the file that we want to track, and it keeps them in this special area called the staging area. When we did this, I went ahead and I went to the file, the actual file, and I changed this from an empty document to change A. So the empty document now contains some text. Now, Git is smart enough to say that, hey, the snapshot that I took 5 minutes ago, it's different from the file at this point in time. So now Git knows that the file, the story.txt, is different from the snapshot it took, right? So the snapshot was like a photograph with an empty document, and now the file contains change A. So Git now knows that the story.txt that I'm tracking has changed. So this is how Git actually started informing you about things that are changing in this file. So the staging area contains like the snapshot, the file. You can edit the file and you can do whatever you want. But now Git can compare these two things, the actual file and the tracked file, the snapshot, and it can give you information about the things that changed. So if I go back to my terminal, this is the part that says, the story.txt that you instructed me to take a snapshot 5 minutes ago has been modified. Okay. So this shows you that the suspect, let's say, moved. So there's something changed. And there's a command that you can run to show you the difference between the current file and the snapshot. So the command is called git diff. Now, this is a little bit too much at this point. It contains some information that doesn't really make sense. So forget about this one. Forget about these things. Don't worry. These are very technical details. What I want you to focus is that, first of all, it says this part. It's like comparing the current story.txt with the story.txt snapshot, the file, the copy of the file that is in the staging area. So A and B, and then this thing here, this is green because the file that was blank now contains an additional line. So this is the thing that changed in the file. We were in a blank state, and now we have this mean in addition, we have this text. Let me change the text to something that contains, let's say, 2 lines, and run the command again. So now you can see that I have 2 new things in the new version of the story.txt. 2 lines, one says change A and another line, and of course yet another line. We will see like the full okay, it's ein, don't worry, but we'll see this. So what git diff does is it makes a comparison. It says I'm going to let's say, so I'm going to compare this. Let's make this, so oops, no. So I'm going to compare these two. Let me put this, I don't know, let me make this a little bit more clear to see. So I'm just going to, so this guy and this guy and this guy, let me, so I'm going to take these two things, which is the current file and the snapshot, the one in the staging area, and I'm going to compare them. So this is git diff. Oops. So if you run git diff, it will compare the current file or folder. This is called the working area. So this thing here is the working area in Git lingo. Basically, it is the folder that contains the files and that you, that you work with. Okay, this is where you actually edit things. And then it's going to compare the story.txt from the working area, okay, with the snapshot from the staging area. Okay, so this is the staging area. Remember, the snapshot is just a photograph, a snapshot that Git took in the past, and it's going to show you the difference. So you can see here visually that the difference between the snapshot and the changes is this change A, or in our case, change A, another line, whatever you put in here, whatever, doesn't matter. So the difference that you also see visually is the thing that you output, that you see in the output of the git diff command. Okay. So just to recap, we had 3 people in the room. We said to Git, I want you to track this guy because it looks suspect. For now, I'm using the detective analogy. And Git immediately took a snapshot of that guy at that particular point in time, which was blank. Okay. And then as this guy or as this file changes over time, or maybe if this was a person, they moved or went to another room, when you say git diff, Git will say, okay, let me compare the snapshot from the staging area with the actual file, and I will tell you if something changed and what exactly that change was. Okay, so that's kind of like the git diff. So we went from untracked to tracked, and then git diff to see whether something changed. If I didn't make a change, or if the change that I made in the file was, just removing the text, the git diff would say that there's no difference. The snapshot 5 minutes ago is exactly the same with the current file, so nothing changed. So the difference, the diff, short for difference, is it's not going to produce any output. So for example, if I go back to my folder and I go back here and I change the current state of the file to an empty and I run git diff, you will see no output because the snapshot is exactly the same as the current state of the file. let me pause here for comments, questions, and I want us all to kind of like understand this both on a very basic high level, on a conceptual level, but also on what we see in the terminal and the folder. So let's take a few seconds to look at what we've been going over so far, and let me know if you have any questions or. Also, if this feels a little bit overwhelming or overwhelming, too overwhelming or intimidating, it's supposed to be because Git is one of the toughest and most notorious software out there. I'll tell you that one of the hardest parts of our work as developers is to deal with Git. So this is difficult, and it takes time to master, and it takes time to familiarize yourself and make sense and understand all these concepts. So you saw so far we've been going through a lot of terminology. So Git is it's tough. I won't lie. It's tough, and it's notoriously tough. There are a lot of memes around, about how Git can go wrong and how people like confuse some commands from time to time. But it's a really powerful tool, and it's something that we cannot work without. So you don't keep track changes of your files and folders and your code. Bad things can happen. So we have to learn about Git. Um, so let me. Yes, Nasrin.
So thank you so much, Costa, for this. I understood that Git, it's, as you said, the most difficult, or you have to use a little bit the tool to understand better. My question is, how can we be familiar with this tool, with Git?
Mhm. So,
The basic things, I mean, you
mhm, mhm.
understand, Costa?
Yeah, yeah.
Thank you.
The Yeah, thank you. So the best way that you can learn Git is by practicing. So creating a folder, initializing it with Git, changing things, running these commands, see what happens, getting the output, getting to understand the output, maybe with ChatGPT or maybe with questions on our Slack forum. What does this command do? What does this output mean? Why do I get this output? But basically is you have to practice. You have to practice these commands, and you have to do you have to experiment. The more you use Git, the more you will become familiar. So it just takes practice, time, and patience. So it's really
Perfect.
yeah.
Yeah, thank you for that. Sorry, another question. How can we get, I don't know if we have a list of this command to try to create a file and to try this terminal in Windows, not like you in Mac
Mhm.
computer. Thank you. And I
Thank you.
think.
It's exactly the same. So
Mhm,
you download Git for Windows. You
mhm,
open up a terminal. I would
mhm.
recommend that if you install Git on your Windows, you will get an extra program that is not available, I think, in Mac. There's something called Git Bash. So not sure whether Windows. Uh, let me see. Basically, let me see if I can find an image. So Git Bash is basically this. Uh, Let me see if I find the screenshot. Basically, is the terminal something that the thing that I'm using, no, a black box or a white box doesn't mean that you can type commands. So you will get something like this. It's basically a terminal for Windows. I highly recommend that you use Git Bash as your main terminal on Windows because it aligns perfectly, almost perfectly with Mac and Linux. So if you use Git Bash, you can communicate and you can use the same commands with a Linux user, with a Mac users. So we are all on the same page. There are other terminals in Windows like PowerShell and command prompt and stuff like that. But if you install Git, you can run all the commands that you saw in exactly the same way. You will see exactly the same output. And with Git Bash, you will also have the same experience with Linux and Mac users. So thanks for bringing this up.
Perfect.
Git
Thank
Bash
you so much
for
to both for this. I will try.
okay, so let's move on to, let's say, the final step to see how we can actually like not just take a snapshot, but also store this snapshot in history. So far, if you want to go here to somewhere like where we can see like the different changes in our document. You can see here's the output of the Google Doc version history, and here's the output of the Git diff. Let me change this again. Sorry, just to see you how Git is changed. Okay, so if I do Git diff, so you see there's a strange output here. There's some geeky information, but there's a green line that says this thing was added. The plus means there was something added. There are two other operations that you can find on Git diff. You have the add, the plus icon. You have the minus, something was removed, and you have like the I don't remember the icon, but there's a blue thing, M, modified. So the same line was modified. So no addition, no removal. It's just that the text was just modified. So for example, I went with change A to change B. So change the last letter. So that would show as a modified. We will see this in a bit. So you can see there's this difference, this comparison, and it looks a little bit like this. So you can see here the state was hello world. And when we change from hello world, welcome to Git intro, you will see this green area, which is basically the thing in the part of the text that changed from the previous state. So pretty similar to the Git output. This is a little bit more user friendly. Now, let me go and change the story txt once again. So I will go here and I will say, let me clear the console. And now let me change this to, I will change this to A1. Now, let's run git status. So we have this modified. This once again is taking the snapshot, comparing it with the actual file, and it shows us that this file was modified. So the snapshot is different from the original file. If I have exactly the same file with the snapshot, there will be no modified line. So the snapshot and the actual file are the same. But if I put this here, you will see it says, hey, this guy was modified. If I change the file once again, 1.1, whatever, you will see that the git diff will show me that from a blank state, we went to the change a 1.1, which means that if I keep changing this file to change 1, A1, Git will constantly be comparing this snapshot, the blank page, with the latest changes in the file. So git diff will show change A1, A.1, and so forth. So I can keep changing. Now, if at some point I want to store a particular state of the file in version history, so I want to save it forever, there's another area in Git, and this is where the term commit comes into the picture. Let me move this a little bit. This is also part of the Git repository. So if for some reason I want this blank, this initial state to be kept in history so that I can always go back and see what I did on September 27, I will have to move the snapshot to the the other area, which is called, let me like this a little bit, which is called the commit history. A commit is a snapshot. So commit is kind of like a so no, sorry, it's slightly different. So commit is when a snapshot is a different thing. When a snapshot becomes something that is saved in the history, in the version history, something that will remain there forever. So the snapshot is a temporary thing; it can change, but this thing will stick with us forever. We can always go back. So if I take now, if I take this and I add this to the commit history, we will have this snapshot stored, converted into kind of like a still frame, if you will, or I don't know, something permanent in our history. So when we want to go from the snapshot to the commit history, we run the second or third most important command, which is the git commit. So the git commit is actually taking the snapshot, and moving it into the commit history. And now this will remain there, and we can always go back in time. Let me do that. So clear, and then git commit. So git commit takes some parameters. So you have to say git commit -m, which is short for message. And I believe I can also git, let me see, I can run git help commit. I will go through just quickly. Don't worry about this. Just trying to remember, or dash message. Let me use them. So git commit dash message allows you to take the snapshot, store it, move it, copy it in the commit history, save it there for forever, and accompany this let's say more permanent snapshot with a message. So now I'm going to take this snapshot from the staging area, move it into the commit history, copy this into the commit history, and also give it a message. So I will go here and I will say that's initial state blank. Just to remember that this was the first snapshot that I took, which contained nothing on the file. Now, before running this command, let me just copy this command. I could show you another command that's also really important, is the git log command. If I type git log, you will see that I get a message that says fatal, so kind of like an error. Your current branch main does not have any commits yet. So forget about the current branch main for now. This is kind of like talking about what we're working at this point. But it says it does not have any commits yet. So basically, this means that the area here, the commit history, does not contain these kind of like snapshots. These not snapshots, these commits. So these things here, when you take a snapshot and you save it in the commit history, these are called commits. So this is a commit. So when you save something in the git commit history, which is going to stay there forever, this is called a commit. So this is kind of like an entry in the version history. Commits in Google Docs are all of these. Commit, the first commit, the second commit, the third commit, the fourth commit. So these state changes that are found in the version history of Google Docs are the commits. So Git uses this term for these things here. These are the commits. In Google Spreadsheet, these are the commits, okay? And in Photopea, these are the commits. All these different changes that we did in the while drawing, these are commits in the history of Photopea. Of course, in these applications, they are not called commits, but in Git, they are called commits. So this is a commit. So now we know a little bit more about what this commit. So if I do git log, it will show me whether I have some history of commits. And as you can see, there's nothing here because we never moved a snapshot from the staging area to the Git history. So there's no commit right here. Let me go here. We are now at an empty commit history. That's why I get this message. If I say git log, it will look at this commit history. And if it sees nothing, it will say, I don't see anything in here. You didn't save anything, so it's empty. But if I do git commit and I move the snapshot and I save it in the commit history as a single commit, you will see that the git log shows a different output. So I will go to the here and I will say git commit message initial blank commit, because the snapshot is an empty file, right? The snapshot that we took was when the file was empty. So I put this here. Everything looks okay. So now the snapshot is copied in the commit history, and you can we can go and see and check what's in there. So if I go here and now type clear and git log, you will see a different output. So we have one commit. So we did save one thing in the Git history. There's some strange looking numbers here. Don't worry about that. Here is the author. I did the commit. Here's when I did the commit, September 27, around 1 minute ago. And this is the commit message. So now I can always go back to this commit. I can always go back to this step and see how the file looked like on September 27, 0.2. If I want to keep save state changes to the Git history, and that's one of the difficult parts to kind of like understand in Git, or at least get familiar, is that let me give a simpler kind of like output here. So we have the staging area. Hope this make it a little bit. So we have the Git working area where we work with our files. We have the staging area. So short-term snapshot area. So this is where we keep we take photographs that are temporary, short-term, and then this is where we have like the Git history of commits. So if you want to think as Git having this taking these snapshots and remembering things and then saving things in the history with kind of like a long-term memory, this is kind of like the short-term memory of Git, right? The staging area is shorted, and this is the long-term memory. Okay. Just like our brain works in short-term memory and long-term memory, like I make a plan of like a shopping list, like what I'm going to buy this evening in the supermarket. So I take a snapshot. I say, okay, let me buy milk and coffee and eggs, whatever. And then 2 days or 3 days from now, I will not remember that list, right? But if I want to save something in long-term memory, for example, I want to keep the Git commands in long-term memory, I will have to find a way to store this, to move them from the short-term memory into the long-term memory. The way that we do this, I mean, as humans, is like we practice and we go through the details again and again. So Git commit does this. I practice and I do this every single day until at some point this is stored in the long-term memory of my brain. And now 10 years from the first time I saw Git, I remember, git add and git commit. With Git, you have like your your actual work, and then you can take snapshots and you can move them from the once again I'm using, so you can go to this short-term memory with git add. Okay, so git add, take snapshot. If you want to store this memory, you want to keep it forever, you can say git commit and save forever. Okay, so this is the process. There's not like make some changes in a file and then save them. You have to go through this intermediary staging area. You have to take these short-term snapshots with git add and then move on to the git commit and save forever. Why? Because this intermediary short-term stage helps us track some changes that are short-term, that are like things that we want to see and compare with our current work when we do very, very small temporary changes and experiments. So usually you don't want to store everything all the time in the Git history, because if I go from like, let's say, hello to hello world to, I don't know, I decide to go hello world. I make some changes in my text, or maybe I say, okay, I need to go to the capital. You can either store all these changes in your version history, and if you go to your version history, you will see hello, hello world exclamation point, hello world exclamation point, and uppercase, or you can just say, just save this one. Like, I just want to save this in the long-term memory. So it's up to you to take snapshots and then store them forever in the Git like long-term. So really quickly, I want to wrap up with just running a few commands again, just to show you like the basics. So now I am going to make some changes to the story txt. Here's what I'm going to do now, and I'm going to leave you to practice. So story has like had this, let's say, blank. Whoops. Okay, so I took a snapshot and then I saved it into the Git history. I'm going to run this cycle two more times. So I'm going to go to change A, and then add it to the Git staging area. So once again, I'm going to move this here, and then also move this to the Git history. And then I'm going to change the file again, change B, and just quickly copy all these things here. So starting from a blank state, save this into Git history by going through git add, git commit, changing, git add, git commit, changing again, git add, git commit. So all these changes that I will make through my editor will become part of the Git history. So at the end, Git history will contain all these long-term, let's say, snapshots or things. So at the end of this last like session with the terminal, the Git history will contain these logs. It will contain a permanent snapshot, or a permanent, let's say, copy of the initial state of the story txt with nothing, another commit, okay, another long-term snapshot or photograph with change A, and then another one with change B. And in order to go from this first step to this and then to this one, unfortunately, at least for the beginning, I have to run quite a few commands. So it's not as simple as git save or something like that. So let me go through this really quickly just to see how you can. So I will say git status. Now let me go back to the initial like empty file. Okay, now this is an empty file. The log contains one commit that I made with the initial blank. So both my file contains a blank page, and the first commit, the first save that I have in my commit history contains the story.txt copy with blank. I'm going to change this to change A. So now if I run git status, it will say, okay, something changed, and you can stage it. So this means that these changes happened. The file was modified. So from a blank file, now we have change A, and I didn't stage them. I didn't snapshot them to put them in a staging area, the middle layer. So I need to run git add to move them from the working area to the middle layer, which is the staging area. So I will say git status now. So now it's going to green. And now it says that you can now commit this. So now from the staging area, I can optionally move them to the git commit, the last layer, the last box, which is the permanent like long-term memory. So I'm going to say git commit message, or there's a shorter version of this option. So it's single dash m. These are exactly the same. The one is shorter with 2 characters. The other has. So I can say changed to change A, just a message, a silly message. And if I now clear the console, git status will be clean. There's nothing that changed. Everything has been staged and moved to the git history. So it's clean. And if I do git log, you will see that I now have 2 commits. I have the initial commit on September 27, 1902, which was the blank commit, and then have another commit, which is the changes from blank to change A. Once again, I'm going to change this to the character B. So now the working file contains change B. The last snapshot that I took with the git add command contains change A. So if I compare the working area, the working file with the staging area, I will see now, you can see it's a little bit different. So it sees this as removing this line and adding this line. So basically, okay, the same line, but I changed the last character. So working file compared with a staging area is different in this data. And now I'm going to move it to the last layer to save it in the git history forever. So git commit m, let's say content is changed B. It's changed B. Sorry, I didn't move it from the working area to the staging area. I have to move it from, when I save, I have to move it from the working area to the middle. So git add story. Remember, you have to do this again. Working area, git add, moving to the middle layer, the staging area, saving it to the git commit history with git commit. And now I press the up arrow to go back to the previous commands. So I find the last command, and now it's saved. So I do clear git log, and now I have my git history, the initial state, the change A content, and the change B, with all the details that I might need. You can get a shorter version of the log with 1 line. This is another option. So this will help you give a like shorter. And this is a special code, a special unique ID for each commit. You can see this is the same like this one. This is the same like this one. This is the same like this one. So basically, this is kind of like an identification. Every commit has its own unique number. This is a big number, a big string, which identifies each commit because they are all different. For now, you don't have to worry about this number, but we now have our version history. So this is the Git version of the of this thing here. This is the version history in Git in Google Doc, and this is the version history in Git. And we can run this on any folder, on any types of files, so we can have this history. I don't want to go into other commands such as how can we switch and we go back. So I don't want to fill you with too much information. I think it's really a lot. I will now pause, and we have just let's spend a few minutes to just do a quick recap and then some questions. It's a lot, I know. Don't worry. Go through it again, ask questions, practice, experiment with the commands, Google, go to ChatGPT. Eventually, you will get the hand of it. So we have folders in our system, which we can do anything we want: create files, folders, delete them, change them. By default, whenever we make a change, we cannot go back to a previous state. If I change a file or I delete it, and also if I put it in the trash, it's almost impossible to bring it back. And especially if I change the content of files, going back 3 days back, what was the content of the text file 3 months ago, it's impossible. So Git is a program that you download, you install, and you take a particular folder or folders. You can run this command on any folder on your system, and you basically run git init, and you turn this simple folder into a folder with superpowers. This folder is called Git repository because you can now track changes across time. You work in your files and folders as usual. You open files, you save them, delete them, whatever. If you want to start to start tracking some files, you run the git add command, which basically takes a snapshot of one or more files and move them in the staging area. And then you work, and you can compare with your current work and the last snapshot of a particular file or files. You can use git add with more files. So I could run git add temp.txt, git add secret.txt, and so forth. And then when you have your file in a state that's really important to you, let's say I wrote the first chapter to my book, you can move your snapshot from the staging area to the commit history area, which is the long-term memory. Kind of like this is where Git keeps information and remembers them forever. So if you want if you like the changes that you make at a particular point in time and you want to save them in the Git history forever, so that you can go back, or if you do a mistake, you can revert, you use git commit along with a message to save that in your commit history. This was like a kind of like a broad overview, and I know there's a lot to digest. Don't worry, Git it's hard. Let me know if there are any questions or things you'd like to discuss before we wrap up. I think we can spend just a few minutes if you have any questions, or maybe some parts of the diagram are not clear enough. One thing that I didn't cover is the third state of the files, which is ignored, completely ignored. So you can also tell Git, like, forget about this file forever. It means it will not show even as untracked. So there's another state you can say, this file is there for me, it's I don't know, it's not important. You can just hide it from your view. So ignore means that some files will be invisible to Git. It will just won't see them. So I didn't cover this, but we'll leave it for you to discover. So that's it for today. Thank you all for your patience, and I will see you on Slack. So thanks everyone.